chapter is quadratic form. So this is next is quadratic forms. Quadratic forms. So that is our next chapter. So what is quadratic form? So first go to the definition. It is a homogeneous polynomial of second degree in any number of variable is quadratic form. So what is this? So it is a homogeneous polynomial number one. Number two, of the second degree of the second degree in any number of variable, in any number of variable, of the second degree in any number of variable is called quadratic form, is called a quadratic forms. So first remember, it is a homogeneous polynomial, number one. So it is a homogeneous. Number two, it is of second degree. For example, 2x square, its degree is 2, plus 4xy plus 3y square. So it is a homogeneous equation of degree 2, homogeneous polynomial of degree 2 and variable x and y in this case. So this is called a quadratic form. Now similarly, in case of three variable, x square plus y square plus 2z square plus 2xy plus 3yz plus 6zx. So it is a homogeneous equation, polynomial of degree 2 and in variable x, y, z. So it is also called a quadratic form. Now this quadratic form can be written in this way. So in the general way, so this can be written as summation of j running from 1 to n and summation of I running from 1 to n aij xi xj. So this is a general form of quadratic form in n variables. So here variables are x1, x2, x3 and so on up to xn. So when I and equal to j, so we get a11, a12, a11, a22, a33 and so on, and it is a coefficient of the square terms which is a xi square, right? So in this case aii coefficient of xi square. When I is not equal to j, so we get two values, one is aij and second is aji. So which is a coefficient of xi and xj, this values. Now it means from this we get a new term which is a sum aij plus aji. So this is aij plus aji. If it is a symmetric matrix, if we write it in the form of a matrix form. So that is equal to X transpose A into X. So this is X transpose A into X. So we will understand with example. So just note down the general quadratic form. So general quadratic form, which is equal to summation of Aij, Xi and Xj. So which is again summation, which is a j is running from 1 to n and I is running from 1 to n. So this is a general quadratic form of a quadratic forms of n variable. The variable are x1, x2, x3 and so on up to xn. Now each quadratic form can be written in this way. So each quadratic form can be written as summation of Bij, Xi, Xj in this summation, where it is summation j and I running from 1 to n. So every quadratic form written in this way, or where B matrices, it is a symmetric matrices. Bij, which is a symmetric matrix, coefficient of symmetric matrix. So it is a coefficient of symmetric matrix, symmetric matrix, symmetric matrix, symmetric matrix. Now, quadratic form, basically it is a product of matrices that we written in the form of X transpose. If I take, suppose, let A is a matrix which is equal to A11, A12, A1n, A21, A22, A2n and so on, AN1, AN2 and ANN. So this is a matrices A matrix, and next is X matrices, which is a column matrix of n variable. So this is a x1, x2 and so on up to xn. So remember these values. Now this can be written as, the quadratic form can be written as X transpose into A into X, this values. So this value can be written as X transpose mean x1, x2 and so on up to xn. So this is a transpose of X matrices. And second is A matrix. So this matrices is A11, A12, A1n, A21, A22 and A2n, AN1, AN2, ANN, and next is this matrices X, which is x1, x2 and xn, right? So I write these product of matrices. So in order to simplify this equation, so simplify this product, so it is very easy to prove that this can be written as summation of, this is second summation, which is Aij, Xi, Xj, which is j is running from 1 to n and I is running from 1 to n. So this quadratic form can be written in this form, which is X transpose A into X. So remember that the quadratic form can be written as the product of matrix, product of these matrices. Now for example, if I will take the example of I2, I is running from 1 to 2 and j is running from 1 to 2, for example. So I will understand by using the example. For example, if I take a quadratic form of order 2, so which is a summation of j running from 1 to 2, summation of I running from 1 to 2 into aij xi xj. So this can be written as, this is a maximum power is 2. So this can be written as a11 x1 square plus 2 a12 x1 and x2 and plus a22 x2 square, this values. Now this can be written as, where A is a symmetric matrix, so we will discuss. So this can be written as, so from this, which is equal to x1 and x2, because it is a 2 variable, and second is matrices this, and this matrices is symmetric matrices a11 a12 a21 a22. So both of these are equal, and here we get x1 and x2. So this is in case of 2 variable. Similarly, in case of 3 variable, so just to take another example. So here if we have the example of 3 variable, so j is running from 1 to 3, I is running from 1 to 3, so aij xi xj, this value which is equal to, so this value is equal to here a11 x1 square plus a12 x2 square plus a22 a33 x3 square plus 2a12 x1 x2, remember that, and second is plus 2a23 x2 and x3, and third is 2 times a31 which is x3 and x1. So this is a example of order 3. So here the variable are 3. So this can be written as x1, x2, x3, and here the symmetric matrix which is a11, a12, a13, a21, a22, a23, a31, a32, a33, and this is second is x1, x2 and x3. So this values. So this is a quadratic form. So this is a product of quadratic form. So this is a quadratic form in 3 variable. So in this way we can convert the quadratic form into the product of matrix. Now first question. So first question, या first example. So this is very important type. So just understand. Obtain the matrix. So first is obtain the matrix. Obtain the matrix. Obtain the matrix corresponding to the quadratic form, corresponding to the quadratic form. So what is the quadratic form? Which is x square plus 2y square plus 3z square plus 3z square plus 4xy plus 5yz plus 6zx. Now solution. So this is a given quadratic form. Now just understand the method, how we will write this in the matrix form. Now in this case, the given quadratic form is, so that is the given quadratic form. So this given quadratic form, this can be written in this way. So first write the coefficient of x square plus 2xy plus 3xz and so on. So just understand, we have three variables. So this is treated x, y and z. So just understand, we have three variables x, y and z, right? Now if we have three variables, so we have the matrix in three variables x, y and z, these values. Now again we get the matrix of 3 by 3, and again where it has x, y and z, these values, right? Now these are the coefficient of diagonal entries x, y, z. So 1, 2 and 3. So remember, coefficient of square variable, these are the diagonal entries 1, 2 and 3. So first write this. Now this is this xy, this is a A11, A12, right? And this is a A12, also it is a A21. So what is this? This is from A23, because y is second. Because we have three variables 1, 2 and 3, right? So 1 is x, second is y, third is z. So if we have xy, then we will get A12 or A21. When we have variable yz, then we have the coefficient 2, 3 or 3, 2. So in this way. So from this 5 is from A23 and A31. Similarly, 6 is from A31. Because we obtained two values. A12 and A21. So basically it is A12 plus A21 equal to 4. Similarly, A23 and A32 equal to 5. A31 plus A13 equal to 6. Since matrices are symmetric, so they are equal. Similarly, they are equal. So what is its value? It is the half of this. So A12 is 2 and A21 is 2. So just write, right? So divide it by 2. So this is A12 as well as it is A12 as well as A21. Similarly, in case of this, so again divide by 2. So it is second and third. So this is 5 by 2. This is second, third to 5 by 2. These values. Now what is this? It is a 3, 1 and 1, 3. Divide by 2. So this will become a 3 and this will become a 3. So this is it. So in this way we can write in the form of this matrix. So what is this? This is a X transpose. So we write it as T Z dash. And this is a matrix and this is a X matrix. So what we get? We get A matrices, which is diagonal matrices. So this is equal to 1, 2 and 3, 5, 2, 2, 5 by 2, and here 3, 5 by 2 and 3, this matrices. So this is X matrices. So what is X matrices? Which is in a column matrix, which is in the form of X, Y and Z. So this is a 3 variables, this values. Now in this way we can find out the corresponding matrix of the quadratic form. So clearly this A is symmetric matrix. Clearly A is symmetric matrix of order 3. So in the quadratic form, this matrices will be clearly symmetric matrix of this kind. So in this way, we can find the matrices from the quadratic form. Now in the second part, the matrices is given. Now we want to find out the quadratic form. So question number 2. What is the statement of question number 2? Which is write down, the statement is write down the quadratic form write down the quadratic form corresponding to symmetric matrix. So the given is a symmetric matrix. So remember that, symmetric matrix. So what is the symmetric matrix? So this is a 1, 2 and 3. So this is 1, 2 and 3, 2, 0, 3, 2, 0, 3 and 3, 3 and 1. So this is a symmetric matrix. Clearly it is a symmetric matrix. Now how we will find the quadratic form? So what is the solution? Now this is a matrices of 3 variable. So just you can write it as X matrices as of 3 variable, which is x1, x2 and x3, and this matrix is written as A, which is of this kind. Now quadratic form can we find out from the equation X transpose A matrix into X. So what is this? This is a x1, x2, x3, and the second is A matrix, this values, which is 1, 2, 3, 1, 2, 3, 1, 2, 3, which is 0, 3, 0, 3 and 3 and 1, this values. And here it is again x1, x2, x3. So this value is x1, x2, x3. Now multiply this matrices. So we get first multiply this term, which is equal to x1, x2 and x3. This. Now multiply this matrices, product of these matrices, which is first x1 plus 2x2 plus 3x3. Second is 2x1 0x2 plus 3x3, and third is 3x1 3x2 plus 1x3. So this is, now again multiply this. So first equation is multiplied by x1. So what is x1 into x1 plus 2x2 plus 3x3. Second is with x2. So this is x2, 2x1 plus 3x3. And third is with the help of x3. So which is 3x1 plus 3x2 plus x3, this value. So first find the power of x1 square, x2 square. So this will be x1 square from this plus x2 square. So here it is 0. So plus 0 x2 square plus x3 square, which is 1, x3 square plus this values. Now x12 from this and from this, 2 plus 2, 4, x1 and x2. And next is x21. So here x12 and 21, x23. So x23 is from this. So this is a 1 is 3, 2, 3, and 1 is again 3. So this is a 6, x2 and x3. And third term is x31. So here it is 3, here it is again 3, 1, 3. So plus 6, x3 and x1. So this is a quadratic form from the symmetric matrices. So what is the quadratic form? So quadratic form of the symmetric matrices. So this is a quadratic form of the symmetric matrix, which is x1 square plus x3 square plus 4 x1 x2 plus 6 x2 x3 plus 6 x3 x1. So this is my result. So in this way we can find out the quadratic form from the matrices, and similarly we can find the matrices, symmetric matrices from the quadratic form. So we did 2 questions. Now the question number 3 is, find a real symmetric matrix such that, it's very important. So what is statement? Statement is, find a real symmetric matrix. Find a real symmetric matrix C such that find a real symmetric matrix C such that Q is equal to X transpose CX, which is equal to x1 plus x2 raised to power 2 minus x3 square. So this is the statement of the question. So it is nothing complicated. So just first find the quadratic form. So what is the here quadratic form? So that we easily see that x1 square plus x2 square minus x3 square, right? Now next, plus 2x1 x2 plus 0 x2 x3 plus 0 x3 x1, this value. Now this can be written as simply this can be written as in this way. So which is x1 x2 x3. So here this matrix, here again 3 variable x1 x2 and x3. So first write the diagonal entries. So diagonal entries are 1 1 and minus 1. So 1 1 and minus 1, right? Now this is a coefficient of 1 2. So divide it by 2. So this is 1. So here it is again 1, here it is again 1. 1 2 and 2 1. So here is 0. So divide by 2, again 0. So 2 3, second term, this is second, 2 3 and 3 2. And last is 1 3, again 0 and again 0. So this is a C matrix. So this is a C matrix. So what is this? Which is a X transpose. This is a C matrix. So this is a X. So that is my result. From this we can find that the symmetric matrix, which is 1 and so on. Now in this case we can find the symmetric matrix from the quadratic forms. Similarly, the next questions are very important. So again write down. So write down. So these are very important questions. The quadratic form, corresponding to the following symmetric matrix. Symmetric matrix. Following symmetric matrices. So first matrix is, this, and second matrix is this, right? Now first matrix is 0 1 2 3 1 2 3 4 2 3 4 5 3 4 5 2 3 4 5 6, this. And this question is asked in 2017. So this question is asked in GNDU 2017. And second is 0 A, B and C. Next is A0 L M, BL0 P, BL0 P, and CMP0, CMP0. And this is asked in GNDU 2016. Now, here there are 4 variables. So this, if it is a matrices, this is A matrices. So this is again A matrices, right? So how we can find the quadratic form? I just gave the hint. So do it yourself. So I will find the quadratic form Q X transpose A into X, right? So just what is X transpose? Which is a 4 variable, X1, X2, X3, X4. Then write the matrices A, again X1, X2, X3 and X4. Now simplify. So product this matrices. So we get the result. So we get the result of the quadratic form. So in this way, we can find the quadratic form of the quadratic form from the symmetric matrices. Now next article is linear transformation. So next article that is related to linear transformation. Linear transformation. So just remember that if we have 2 set of variables, let x1, x2, xn, this is one set of variable, and y1, y2, yn. So these are 2 sets of variables. Step number 1. So these are 2 set of variables. One is x1, x2 and second is this. Now consider a system of linear equation. System of linear equation. Now consider a system of linear equation. For example, y1, y2, y3, y4. So first y1, which is equal to p1 x1 p2 x2 pn xn, and second is y2, here p11, here we write p11 p12 p1n, and next is p21 x1 p22 x2 p2n xn. So yn, which is pn1 x1 pn2 x2 plus pnn xn, this values. Now in matrix form, these system of equations can be written as, this is from this, what is this? This is a y1, so this is another matrix, and this is another matrix, right? So here this is a y1, y2, yn. This is a x1, x2, xn, and this is a p11, p12, p1n, p21, p22, p2n, pn1, pn2, pnn, this values. So what is this? It is a Y matrix. What is this? It is a P matrix. What is this? It is a X matrix. So Y can be written in the form of Px, where P is this matrix. So if P is non-singular, non-singular means which is invertible. So if P is non-singular, if P is non-singular, then it implies it inverse exists. So it implies its inverse exists. It is a invertible. If its inverse exists, then it implies X can be written as P inverse Y. So from this equation, we can write it as P inverse Y equal to X. Then what we get? We get 1-1 correspondence between X and Y. So in this way, we get, so there exists 1-1 correspondence between X and Y, between X and Y. It means Y determine the value of X and X determine the value of Y. So it means there exists 1-1 correspondence between X and Y. Now this is a system 1 and system 2. So system 1, this X equal to Py, system 1. So it determine a linear transformation. This linear transformation is singular if P is singular, if linear transformation is a non-singular, if P is a non-singular. So from this, what we get? We get there exists a 1-1 correspondence between X and Y if P is a non-singular. So remember this. Now next is resultant of two linear transformation. Now consider two linear transformation, two linear transformation defined by matrix equation as we defined already as y equal to px. So one, I am taking y equal to px, and second I am taking z equal to qy, right? Now what is the resultant? So resultant can be defined by a single equation. So just substitute the value of y in this equation. So what is z? Z is qy. So write the value of y, which is q px, so which is a qp into x. So this is a this is a resultant of two linear transformation. So in this way we can find the resultant of two linear transformation. So just to remember that. Now in order to understand this concept, now I am taking the example. That example is, given the matrices, first question, first example, given the matrices, give the matrices of corresponding to following linear transformation. So following linear transformation. So in this case the linear transformation is given and we want to find out the corresponding matrices. So what is the linear transformation? First, y1 which is equal to x1 minus 2x2 plus 3x3, y2 which is equal to 2x1 plus x2 plus x2. Third term is not given, so I write it as 0x3. And next is y3 which is equal to 3x1 plus 4x2 and then minus 5x3. So this is a given linear transformation, right? Now this transformation can be written in the matrix form. So how we can write it in the matrix form? So solution. So you write in the exam, this transformation can be written in the matrix form. So this is a matrix form is y1, y2, y3. So this values. Second is from this, and third is x1, x2, x3. So what is this? This which is a 1 minus 2, 3, 2, 1, 0, 3, 4, minus 5, this value. Now clearly from this, if this matrix is a non-singular, invertible, then we can also write it as x equal to P inverse y. Now from this can be written as y which is equal to P which is into x. So what is where P is equal to this matrix which is 1 minus 2, 3, 2, 1, 0, 3, 4, minus y. So this is our required matrix. So very simple. So just find the matrix. Similarly, if matrix is given, then we can find the transformation. For example, I am taking the next example. So give the linear transformation corresponding to following matrices. Now here matrices is given. So this is a matrices which is 1 minus 2 minus 5, and next is 0 7 minus 1, third is 2 3 4, 2 3 4. So my aim is to give the linear transformation. So give the linear transformation corresponding to the matrix A, which is equal to this values. So this is a statement of our question. Now this can be written as solution. So the given matrix required transformation is, so right here required transformation is y1, y2, y3, number 1, and then the matrix, so which is a 1 minus 2 minus 5 0 7 minus 1 2 3 4, so which is x1 x2 x3, this values. Now in this way, so from this, in this way, so just to simplify, it implies, so first we get y1, which is equal to x1 minus 2x2 minus 5x3, y2 0x1 7x2 minus x3, y3 2x1 plus 3x2 plus 4x3. So that is a given linear transformation. So in this way we can find the linear transformation from the matrices. So we did the both type of question. From the first, we can find the transformation from the matrices, and in the second part we find the matrices from the linear transformation.